Okay, so since I didn't record it from the beginning, y'all don't want to hear it again. The people who are on the recorder will see. There's the rule. You add 1 to the power, you put the reciprocal out front. And I wrote it under here because I'm going to work these examples using that power that the kids that were here from the very beginning got to see. Now, so if you were going to work this one, you were going to integrate this one, all you have to do, and the parentheses here to me are a pain, but what they're showing is that's really x cubed times dx, x squared times dx. They're showing that this could be written as 3 or 4 separate integrals. Don't do that. That will mess you up. You simply write this one down. Add 1 to the power, put the reciprocal out front. Put your plus sign, write down your 4. Add 1 to the power, put the reciprocal out front. Minus, add 1 to the power, put the reciprocal out front. And on this one, I want to put an x to the 0 right there. What happens when you add 1 to that 0? You get x to the what? First, right? And so then you will get x to the first, and there's no reason to put a reciprocal of 1 out front. And then your plus c. And that, folks, is a nice little basic, get you started integral. All right? You add 1 to the power, and you put the reciprocal out front.
So do we have to add the parentheses and the dx still?
The dx has to be there, and I am going to tell you to put the parentheses there because that's how it's going to look in books. What I always did is I always just assumed, or I always just knew the parentheses was there, and I didn't ever put them in. You have to have the dx, all right? And I can go ahead and tell you why you have to have the dx, all right? I'll show everyone why you have to have the dx. But I'm going to let you write that one down, and since you asked that question, I'm going to show you. Everybody ready for why you have to have the dx? Okay, here's why. If you have x plus y dx, you treat the y as a constant. You treat the y as a constant, and you only treat the x as a variable. All right? So if you were to integrate this, you would get 1/2 x squared plus, now if you had a 5 or a 6 here, and you were integrating, you get 5x, right? So you're going to get yx plus c. You treat the y as a what? Constant. Now, if you had this, I'm off the screen there, if you had this, what would that tell you? X is a constant and y is a what? Variable. See the difference? So that's real important to put out there. Honestly, since everything that y'all are going to have in Calc 2 up until maybe the very end of the course, Calc 3 is when you get into this. But don't start leaving this off in Calc 2 because it will mess you up in Calc 3. All right? Yes, sir?
Will you ever have multiple?
X, yeah, dx, dy, and the same problem.
Yeah.
That's right, you sure will. That's multivariable calculus. That's Calc 3. But that's the reason it's important to go ahead and have that there. Don't not put that there. Okay. Now, back to the most basic of today. Algebra is your friend, because if you know any algebra, that is x to the 2/3 dx. Simply use your rule. Add 1, 5/3, with the reciprocal out front, plus c. I know this man's majoring in like something other than science or math when he goes to college. And I know this young lady's not going to take Calc 2 in college because she's reading about the July Revolution of 1830, which is not calculus. All right. This one, make it x to the -3 plus x to the -1/2 dx. And that really should be in parentheses, but like I say, I would leave them all. Notice if you can rewrite it into a polynomial, you can just use the rule. That's what makes life good. So you add 1 to that, put the reciprocal out front. Add 1 to that, put the reciprocal out front, and put a plus c on the end. If you're at MIT and you don't put the plus c on the end, they don't care because they know you know it's there. Okay? If you're at MIT and you're doing their integration work, if you don't put the plus c there when you do an indefinite integral, they don't worry about it because they know you know it's supposed to be there. All right. Okay? Is that pretty cool? Now, there is a problem. Before we do, there is a problem. Let's do this example. X cubed plus x over x dx. Does everybody realize you can reduce that to x squared plus 1 dx? Put this one over x, put this one over x, and then once you get it here, just integrate it. And just remember, when you have a constant, that's going to produce a constant with the x plus c. All right, so there's one. So any of these that you're going to see today, you're going to be able to rewrite them into this form. Now, here's the problem. We're going to rewrite that x to the negative 2 plus x to the negative 1 dx. And we're going to use our rule. Add 1 to that. Get x to the negative 1. Put the reciprocal out front is negative 1. Plus x. And we're going to add 1 to negative 1, and what are we going to get? 0. And if you put the reciprocal out front, you get 1 over 0. Bad. Bad. Bad day. Okay. The rule that I gave you to begin class with only works if n does not equal, or the power does not equal negative 1. Power does not equal negative 1. This rule that I gave you that rule only works when p does not equal negative 1. It works for every power except negative 1. It works for fractional powers. It works for every power except negative 1. Well, that was a bad day for the mathematicians because all of a sudden they didn't have anything that they knew that you could take the derivative of and get 1 over x. So the mathematicians are scratching their heads and they're wondering, uh-oh, if we have 1 over x dx, or we have x to the negative 1 dx, we have a problem.
The natural log.
Natural log of absolute value of x plus c. The natural log function is a transcendental function created to deal with that problem. The natural log function is a transcendental function to deal with that negative 1. All right? Now, honestly, I'm not even supposed to teach that until you've done a bunch of these, but somebody eventually realizes that x to the negative 1 is not going to work very well. So let's go ahead and talk about what gets rid of that, what deals with that. Now, this would have to be a power of 1 here, right? I'll realize that has to be a power of 1. But that's what natural log functions are all about. They were actually created in calculus to take care of integral calculus. All right, well, to make this a little better, Mr. Evans went to the trouble, because he considers this important enough, to run off pages from Mr. Lighthole. We're not going to do pages from chunk books. We're going to do pages from Mr. Lighthole. Please do not ask about the trig problems yet, because we're going to do trig its own little baby by itself. But if you pick out any even number on the page from 2 to 30, 2 to 30, 2 to 28, we will do it on the board together. You pick out an even, 2 to 28, and we will do this together. So I don't expect you to do any homework. I know you're seniors. I know it's spring. I just want you to be able to survive Calc 2 in college. And here we go. You pick one and we'll talk about it.
13.
13. That's not even, but I'd pick out one like 13. I mean, I would work 13. I don't have a problem with that. Which one? 14. 14. Here we go. 14. I really want to work number 10 first.
Okay.
Let's work number 10 and then we'll work 14. Yes, ma'am. You doing this or you doing something else?
No, I was calculating something else.
Why aren't you calculating this?
I'm sorry.
No, what are you calculating?
I was planning for a program at Tulane, and I had to like make sure that I had all my credits in order.
I like that. I can live with that. You're a senior. Integral 7x cubed times square root of x dx. You cannot use our rule because you got x's times x's. But what could you do to make this a better problem, dear children?
Make it x to the 1.
Make that x to the 1/2.
And then combine them.
And you get x to the what? 7 halves dx. Because that's x to the 1/2, and 3 plus 1/2 is what? X to the 7 halves. I won't mention while we're on camera that some of y'all can't add fractions.
I can't add fractions.
Well, then, bad day. Now, what I would do with this, if I was going to use the rules, I'd write my 7 down, skip a space, add 1 to that, which is 9 halves, and then put the reciprocal out front. And then you get 14 over 9, x to the 9 halves.
Why did you do 7 over 2?
Okay, 3 plus 1/2 is 7 over 2.
Okay.
Yeah, because when you multiply them, what do you do to the exponents? You,
You add them.
yeah, so 7 halves.
I already know I'm going to forget the C at the end.
It's all right.
And why are you adding 2 from one line to another?
Okay, you always add 1 to the power and you put the reciprocal out front. You add 1 to the power and you put the what? Reciprocal out front. Filling out two lane applications. Which probably already tells y'all how to work 14. Is everybody happy with that one? That's a little trick just from algebra. Try to rewrite it. Everybody work 14 real quick. You already know how to work 14. What are you going to do first to work 14?
Distribute.
Distribute it. Yeah, turn it into a polynomial if at all possible. Turn it into a polynomial.
Mr. Evans?
Mm-hmm.
What's polynomial?
Well, distribute the x to the 4th out. How's that?
Okay, yeah. Alright, I can do that.
You know, I'm recording to go on YouTube public for the whole.
It's okay, they don't know who I am.
Well, I'm gonna turn the camera around and show them who asked that question.
Don't do that.
I feel like it's illegal.
I like calling
All right, ready?
You just went.
I bet y'all already know the answer to this one.
That's
I
right.
guess you I don't.
Like, whatever's negative, whatever's seven.
Hooray.
Whoa.
Yeah, add 1 to the power.
Whoa.
Okay, you got the 5. You add 1 to the power, and you put the reciprocal out front. 5 over 5 equals 1. You add 1 to the power, you put the reciprocal out front, and you,
Why wouldn't it be 5 times 5 over 5?
because the reciprocal of 5 is not 5 over 5. What's the reciprocal of 5? 1/5.
No, I'm saying, but you already have the 5.
You've already got 5.
You have 5x to the 4th. So
Okay,
it's
add
just-
1.
Right, that'd be 5.
Now, what's the reciprocal of that 5?
1/5.
And you put 1/5 out front. What's 5 times 1/5?
See, you're skipping steps, Mr. Evans.
Oh.
I need all the Trumpy baby steps.
All right, now, look down at number 26. Look down to 26. Somebody said, Mr. Evans, you said you were going to let us pick. Forget it. Y'all are 18 and 17. You're not allowed to make choices.
Only for president.
Yeah, and I'm not sure I like that.
Trump 2020.
Mr. Evans, what was the answer to that? Okay.
What I just erased?
Why did you erase it?
Well, all right. Think about that one. Use some algebra. Use some algebra skills. Use some algebra skills.
Mr. Evans, I think next year I'm going to call you and hit you up for some tutoring lessons if I have to take this.
Yep. So if you're online, it's $60 for doing Zoom. $60 an hour. Or you can come back home like some kids do on Saturday mornings at $60 an hour at Rhino. Your call. I may go up to 90 next year because I got too many students. And
Don't
I
do
need to.
that. Why would
It's
you?
called supply and demand.
What if I just post you as a friend?
Yeah, what if we're?
A friend with cash. I'm your last hope before the F. And if you have no cash, you have no hope.
You gotta take the F with pride.
Except hope, you always have hope. That's in your name.
Oh, God.
Okay, does anybody know what to do with this one?
Not
Do you make the
Um,
y to the negative 1/2 part?
Yeah.
Okay, you can do that. Y to the negative 1/2. I like that. That's
Let me
a
go to the
smart way to
restroom.
do it.
Wait, why? Okay.
I would have done it a different way, but that's fine because it's easy to explain. And then what she's going to do, what is she going to do with that y to the negative 1/2?
Distribute.
Distribute it, yeah. So she's going to get y 7 over 2
Is it in negative?
plus
No.
2 y to the 3/2 minus y to the negative 1/2. And then she's got a dy still out there on the end. And then you just simply use the first rule that we learned. So your algebra skills are important.
The reciprocal?
Add 1 to the power, put the reciprocal out front. Say it.
You add 1 to the power and you put the reciprocal out front.
Very good. So that was pretty easy. That's going to be y to the 9/2, 2/9, plus 2 y to the 5/2 times 2/5 minus y to the 1/2 times 2 plus c. And those are fun because it's not hard to do. Now, we've actually learned 2 rules today because we've also went ahead and taught you the rule for what to do if you have x to the negative 1, right? We've given you the answer for what to do if you had x to the negative 1.
Wait, can you actually do a problem with that?
Yeah. Yeah. All right. So, if you had, we'll make sure everybody's happy with what was on the board so far. Okay, well, what happens is, if you saw this, x plus 1 over x dx. Okay, the first one is just what? 1/2 x what? Squared. Is that all right? But this one would be x to the negative 1. So what's that going to do? And it's absolute value of the x plus c.
So you would just put an L in absolute value of x in its place?
Yep. Well, no. When you integrate 1 over x, you get natural log of x. You're not just putting something in its place. When you integrate 1 over x, you get natural log of x.
Is it because that's
What
the
if there's,
derivative of it?
What if,
Derivative of natural log of x is 1 over x. Yes, ma'am.
what if there's like coefficients?
Okay, so say you had 1 over 3x, right?
Yes.
Okay, 1/3 times integral 1 over x dx. Just move the 1/3 out front. You remember, you can always move a constant out front. You can't move a variable out front. You can put a constant out front, but you can't put a what? Variable out front. Yes, sir.
Say, it was like, multiple terms, but you'd have, the 1/3 would have to be in all the terms for you to take it
Right.
out.
Right.
So what if that was a term, but you like couldn't take it out?
Then do each one separately. See, oh, okay, everybody listen to this, because what she's asking is I'm going to go ahead and show you. What you're really doing, but Mr. Evans is not having you write in this step because you would go nuts having to write in. What you're really doing when you do this is you're integrating that plus you're integrating that. What you're really doing, if you had,
So you would just split it apart?
right,
But
But
you don't have to do that for this.
we're doing all that in our head. Yeah, we are not thinking split it apart like that for right now. If you're having to split these apart, there is a day when you are going to split them apart, but we're not there yet. Okay? All right. Now, if you see the derivative of something in the numerator and you see the u to the first power of the denominator, and you're integrating that, that gives you the natural log of that whole u part that's in the denominator. Is that okay? All right? Is that cool? Yeah. If you have u to the 1, that would be u to the negative 1 du, and that makes natural log of u. This is a u du form, and that's everything after today is a u du form. So we'll just go ahead and show you that one just because it's there. Now, if you wanted to integrate secant x dx. Now, if you wanted to integrate secant squared x, it's really easy. Secant squared u du is equal to tangent u. And the reason that's true is what is the derivative of tangent u? The derivative of tangent u is what? Secant squared u du. Fair enough? And so the derivative, if you're integrating secant squared, it's real easy. It's a rule because it's just the reverse of a derivative rule that you already know. But if you look, none of your derivative rules made plain old secant x. Okay? What gave you cosine? What did you take to get the derivative? What did you take the derivative of to get the cosine u du? Sine u. And since we talked a little bit about u and du yesterday, you understand if that was cosine 5x, you'd need a 5 right there, right? Okay, I'm teaching this a little bit out of order. For those people.
Wait, are these rules over here?
Yeah.
Okay.
Yes, ma'am. Integral of sine u du is actually negative cosine u plus c. Because when you took the derivative of cosine u, you got a negative over here. Well, the negative times negative would make what? Positive. And when you took the derivative of tangent u, you got that. Secant u, tangent u, du came from just taking the derivative of secant u. And what you'll notice, if you read these from left to right, they're integral rules. But if you read them from right to left, they're what? Derivative rules. And these are all, since there were 6 derivatives that you took, you knew the derivative rules for, 6 trig functions, then there's 6 of these that you know the integral rule for. Now, for those students that go through Calc 1 and they never learn their derivative rules, then they're just crushed, because these are the basic integral rules. And then there's one for cosecant squared. Cosecant squared u du equals negative cotangent u plus c. There's your 6 trig functions that are basic. And the problem is there's more, but those are the 6 basic ones, because those came from derivatives. Derivative of tangent u is secant squared u du. Derivative of cotangent u is a negative cotangent u is cosecant squared. So there you go.
Why do you leave the C out there? Shouldn't that be a number?
We don't know what the number is yet.
But like, for the ones you just did, we left it at C.
Yeah.
Why?
Okay, when you take the derivative, what happens to any number that's on the end? Plus 5. What? So we don't know what number it is, but we know there could be one.
Okay.
We discussed that while you were doing your two-lane stuff.
Okay.
Now, this one's interesting because it's not one of those rules. So, oh, and don't forget the rule that I wrote right here. You realize that was a rule, right? That I wrote right there and I just erased. It's been up there forever. That's a rule, right? Okay. Well, let's talk about this one. Secant u, or secant x. We're not going to worry, we can make it x. That way the derivative is just 1. Secant x, put dx way out there. We're going to multiply that by secant x plus tangent x. And you said, Mr. Evans, you told us you can't put a variable out there and then put a variable out here. You're right. I can't put variables here and then put variables out here. But I can leave the variables and do this. Is everyone all right with that? Cool? Now, I'm going to multiply out the numerator. And I'm going to get secant squared x plus secant x tangent x over secant x plus tangent x dx. I want everyone in here to take the derivative of the numerator. Write down on your paper u equals secant x plus tangent x and take the derivative of it. U equals secant x plus tangent x and take the derivative of it. If you can't take the derivative of that, when you take Calc 1 next year, you're going to have a bad day.
Wait, we're taking the derivative of the denominator?
I want you to take the derivative of the denominator. Just tell me what you get.
The same thing as adult.
Who said that? Yeah, the man on the back row, he's already ahead of me here. Du is equal to secant x tangent x plus secant squared x. And then you put a dx out at the very end. What happens is, there is your u with a power of 1 above it. And all of that is your what? Du. Everybody got what? Yeah. So this turns out to be natural log secant x plus tangent x. And somebody earlier said, would you use this rule? Yeah, I just did it. Because what I did is there's a du in the numerator, and there's u to the power of 1 in the denominator. And if you brought that up, it'd be u to the negative 1. And so, as soon as you see u to the negative 1, you know it's got to be what? Natural log. Yes, ma'am?
I just need to look at it for a second.
Okay. And that gives us the rule. And that creates a rule in just a second. We'll write u du form, and that's a rule. But when you integrate secant of something, you don't want to have to do all these steps. You just want to know that we just derived a rule.
Okay, I still don't really get it.
Okay, you know how to take the derivative. What do you get when you take the derivative of secant x?
Wait, say that again?
What do you get when you take the derivative of secant x?